Today we're going to go over Ohm's law, define what Ohm's law is, which consists of voltage, current, and resistance, and define power. Go over a little bit of electrical theory, and go over a little bit about electrical circuit drawing. For you is a basic electrical circuit. So we're going to go over the components. So just the straight white lines, that's simply going to be our conductor. The 4 lines, too long, too short, that's going to be our voltage source. Voltage source, or sometimes it's also called a battery. It's a more colloquial term for it. And here, that's going to be our resistor. Okay, it's important to note that everything has resistance in the real world. There are a few things that have zero resistance. They're called superconductors, but they only happen at very, very low temperatures, so we're not going to be dealing with superconductors. Okay, and by convention, going back to our battery, as you know, has a positive and a negative end. The positive end is going to be here, and the negative end is going to be here. So the long line where it's on the top, that's the positive end, and the short line on the very end is going to be the negative end. So if the long line was, so if the battery was drawn like that, then the negative end would still be here, but your positive end would be down here. Okay, good. So that is a little bit about electrical drawing conventions. Okay. So, what is Ohm's law exactly? Well, Ohm's law says that voltage is equal to the current times resistance. That is Ohm's law. So, what is voltage, current, and resistance? Well, voltage is measured in volts. The symbol is V. That is simply a measure of the electric potential energy. So electrostatic or electrical potential. If you're a fluids guy or a mechanical thinking individual, it's analogous to pressure. Okay? Analogous to pressure. All right. Current is electron flow, electron or hole flow. We'll talk about the difference between electron and holes in just a second. This unit is the ampere. The abbreviation is capital A. And that's equivalent to 1 joule per second of electrons flowing through any given point in the circuit. Okay. R is resistance. You can think of this like friction or pressure head loss or something like that. So it's analogous to friction. It's measured in ohms, and its symbol is omega. Okay, and this is simply a measure of resistance to electron or hole flow. Okay, so what exactly is hole flow or electron flow? Well, electron flow is pretty simple, right? So here we have our positive and negative terminals of our battery, and we know that current flows from high voltage to low voltage, so therefore our current is going to flow around in a circle like that around this particular circuit, right? And it's going to flow continually. However, this is whole flow. Whole flow is denoted as whole flow is denoted as going from high voltage to low voltage, or positive to a negative, right? That is the typical positive direction of current flow. So this is positive current flow. All right, goes from high voltage, high V to low V. All right. Back in the day, we knew that electrons were what made up electricity. Right? The transfer of electrons is what makes electricity. That is essentially what electricity is. However, we didn't necessarily know the direction in which it flowed, so we assumed that it flowed from a high voltage to a low voltage. We knew that the electrons were moving, we just didn't quite know the direction, so we assumed they were moving from high potential to low potential. Turns out this assumption was incorrect. Back in the 40s or so, they proved that electrons flowed from a low voltage to a high voltage because they're negatively charged. Makes sense, right? They flow in the opposite direction. But we didn't want to reconstruct and reteach everybody in the world electrical theory, so we came up with this concept of holes. So holes are essentially mirror images of electrons, or anti-electrons is what you can think of them as. They possess all the same properties, but they're positively charged, and they flow from high voltage to low voltage. So that's the convention that we're going to use. We're actually going to be measuring hole flow. It's the exact same thing as electron flow, except the two just flow in opposite directions to one another. So everything still works. It's just a matter of convention. It just defines the direction of the flow. So that's what we're going to be using. We're going to be using hole flow. So like I said, hole flow is the standard convention worldwide, and it denotes current flowing from a high voltage to a low voltage. Even though, keep in mind, in the back of your head, that's not what physically is actually happening, right? What's actually happening physically is the electrons are flowing the exact opposite direction that we're denoting them as. It's just an FYI tidbit. I'm going to clear that up. Okay? So, let's get back to Ohm's law. Now we've defined what voltage, current, and resistance are. We can move on to defining what power is. Okay, so what is power? Power is, we have a joule per second, and then we have a measure of the electrostatic potential energy. Power is the amount of work done. That is given by the equation P equals VI. Power equals voltage times current. Now we can do some rearranging with V equals IR. We can substitute in the IR for the V in the power term and get P is equal to IR times I, which is equal to I squared R. And we can also solve Ohm's law for I is equal to V over R. Once again, we can substitute that into the power equation there and get P equals V times V over R, which is equal to V squared over R. So therefore, we can actually say that power is equal to voltage times the current, which is also equal to the current squared times the resistance, which is also equal to the voltage squared divided by the resistance. However, you just really need to know this base formula, P equals VI. You can derive the other ones as long as you know also that V equals IR, which is Ohm's law. All right. And that is a basic introduction to electrical theory, how we draw electrical circuits, and Ohm's law. All right. A little quick example of how we can apply this here is by simply taking a standard light bulb. Let's take a 60-watt light bulb, hook it up to your electrical circuitry in your house. Standard electrical circuitry in your house is 120 volts. So this is P equals V, and then we have I over here. So therefore we can see that I is equal to 60 over 120. That particular light bulb has 1/2 of an amp flowing through it. Right? Any questions, come see me individually, and we will talk about more about resistance and how resistors add up in series and in parallel in the next video.